Video, we're going to be learning a lot of cool stuff. I'm going to answer the homework question that you guys had, which was this, and then we're going to start talking about volume, and we're going to go back and revisit these types of problems again, just to make sure that we're all on the same page and we're all on the same, we're all on board with the same stuff. So you were asked to find the area and the perimeter of these 3 slices of pizza, and I asked you to think about how you would go about attacking this. And in my opinion, frankly, the area is probably the easiest thing to find because these degrees, remember, these angles represent a part of 360 degrees because a whole circle is 360 degrees. So you can go and find the area of all 3 of these individually, you know, by doing, because the way we do it, so when we're doing the area of part of a circle, and those are called sectors, those pizza slices. A sector is literally what a pizza slice is, okay? So that's what the area, it's part of a circle, the area of a sector. So, you know, the area of a circle is pi r squared, as we well know. But then what we do is we take the angle and divide it by 360, and this represents the fraction of the circle we're talking about, or what we want to find the area, or even the circumference of, which we'll bring up later. But this takes care of the area of a sector, where you're finding the angle, you're dividing it by 360, and then you're multiplying it by the area of the circle, because that's the fraction of the circle that you want. So you could do 29 over 360 times pi r squared plus 54 over 360 times pi r squared, you know. So you could do that. So you could do 29 over 360 times pi times 12 squared, because the radius is 12, plus 54 over 360 times pi times 12 squared, plus 29 over 360 times pi times 12 squared. Or you can do it in one fell swoop and add all of your angles together. Okay, so that would be 29 times 2 plus 54. Or you could just do 112 divided by 360 times pi times 12 squared. So if I take that, divide that by 360, and then just hit times 12 squared times pi, the area of all 3 slices, the total area of all 3 slices is 140.74 square centimeters. Because remember, it represents, area represents how much space is inside of these 3 shapes. So this takes care of the area of all 3 sectors, okay? So you should check your answer to see if that's what you got. Now we want to get the perimeter of these 3 slices. And if you remember, perimeter is your distance around an object. So when we talk about the perimeter, it's like you start here, you walk here, you go around that arc, you go down here, you walk up this radius, you go around that arc, well, you're going around the arc, you're coming back down, you're going up and around and then back again. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9 things that you have to add up for the perimeter. Now, the easiest things to add up, obviously, are all 1, 2, 3, 4, 5, 6 radii. So 12 times 6, we know is going to give us 72, and that represents all 6 radii. But now our job is to find the length of the distance from here to here, the distance from here to here, and the distance from there to there. And these arcs represent part of a circumference. Remember, the circumference of a circle is 2 pi r. We only want a fraction of the circle. So I'm going to go off to the side, and when we're talking about arc length, okay, that means the length of the arc, which is part of the circumference. Okay. That means, again, we're taking our angle, we're dividing it by 360, because there's 360 degrees in the circle, times the total circumference of the circle. So if we want to get the perimeter that we're talking about, again, this represents our radii. And just like we did with the area, we could do the same thing with the perimeter. We can do 29 divided by 360 times 2 pi r, which is 12. So if we wanted to do that, we can do, 29 divided by 360 times 2 times pi times 12 plus 54, I believe, yes, 360 times 2 times pi times 12 plus 29 over 360 times 2 times pi times 12. You could do all of that, or you could just do the sum of all 3 angles, which we know is 112. You could do 112 over 360 times 2 times pi times 12. And so that would be the 3 arcs. So this is the sum of the 3 arcs right here, plus the 6 radii, So if I do that, 112 divided by 360 times 24 pi, because 2 times 12 is 24, right? I get 23.46. So this just right here is equal to 23.46 plus the 72 gives me a total perimeter of 95.46 centimeters. And remember, this is measured in linear units. Linear means that we're not squaring anything. We're literally finding this distance, adding it to that 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 distance, and so forth. That's why it's perimeter, because we're adding linear things. Area is how much space we're taking in between. That's why we're multiplying things together. And when we multiply things together, we're covering a particular space. I am going to assign another problem just like this one for you guys to do so I can really ensure that you know what you're doing, and I'm assuming that you watched this. Now, we're getting into volume, okay? Volume is a third dimension because volume is how much space it takes up, is how much three-dimensional space is being taken up, how much 3D space is taken up. Which is why we measure in, you guess it, we measure in cubic units. So that's basically saying that if I take like this is a little cube, like how many of these little cubes can I fit into this little space here? Like that would be a cube here. I can fit a cube here, where we're taking up this space. Like how many, say, cubic centimeters, okay? And let's say that this represents, 1 by 1 by 1. So this is 1 cubic centimeter because it's 1 times 1 times 1, okay? And it's how much three-dimensional space, because before we were doing, we were doing length, we were doing width, and now we got to include the height. And that's why it includes that three-dimensional space. That's what makes volume what volume is, right? So we're making these 3D spaces that we're trying to fill with stuff. And we're going to be doing a lot of cool things with volume. And again, it's just a three-dimensional thing of area. Now, we have prisms. We're going to be talking about a prism, okay? Prism. We have rectangular prisms. We have triangular prisms. What makes something a prism is that you have parallel bases. And you are surrounded by rectangles. So the first thing we're going to talk about is we have a rectangular prism, right? It's a rectangular prism. And that's like a box, and that's an easy one, right? So it looks something like this, where you have it. It's a little crooked on my part, but when we talk about it, because it's a prism, it's hard to say, but I'm saying the top, and let's say hypothetically the bottom, right? Typically the bottom, going straight up, right down here like that. And then the bottom are the bases, and the bases in a rectangular prism are shaped like rectangles, right? But you have something like, say, for example, you have a triangular prism. So a triangular prism, this is considered a triangular prism, and the reason why is because the two bases are in the shapes of triangles. So when you have a triangular prism, it looks something like this. Just bear with me here, okay? And if I'm going to go ahead and do my pretty little thing here, okay, you'll notice that you have the two bases are in the forms of triangles, like the top and the bottom, which I'll color in a different color, right? Bottom, 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 bottom. Those are the bases. And then if you notice going around it, if you look to see what actually fills around it, the front of this shape, I hope you're all noticing that the front of this right here, from here to here to here, oh, look, it's a rectangle. Look back here, from here to here to here. Oh, look, that's a rectangle. So from there to there to there, it's called a rectangle. So now what I'm trying to tell you is that this is called a triangular prism. And hold on a second. I think I'm going to add to this real quick. I'm going to add a thing here. So you can have anything like pentagonal prisms, just so long as the bases are parallel. The bases are parallel, people, okay? So you could have something like a pentagonal prism. So if I go 1, 2, 3, 4, 5, right? I can have it where, and then play connect the dots, la, 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 la. And you can see back here. as I'm building my beautiful my pentagonal prism. So this is a pentagonal prism because the two bases, the top and bottom, are pentagons, okay? Now, you don't have to have it where it's like up and down. You can have it where just so long as the two parallel sides are, so long as the two parallel, I can have it going this way, right? I have something that looks like this and, whoops, something that looks like this, and then I can have it where, right? So this right over here, if you look at this, this is still considered a prism, and it's considered a hexagonal prism because there's 1, 2, 3, 4, 5, 6 sides. So this is called a hexagonal prism. Because again, excuse me, because again, the two bases, if I were to highlight the two bases, we have a hexagon here and a hexagon over here. And then if you look around it, it is literally surrounded by 6 rectangles. So this is a pentagon. So your two bases are pentagons, and they are surrounded by 5 rectangles. This one over here is, the two bases are hexagons, right? Those are my two bases, but it's surrounded by 6 rectangles. Okay, so a prism, again, the bases are parallel. That's what makes it a prism, is that you have parallel bases. So I could even have it where I have my triangle going like this, okay? And again, right, my two bases are still parallel to each other, so that is still a triangular prism, okay? So now what we're going to do is we're going to figure out how to find the volume of these prisms. So if you want to find the volume of a prism, again, I didn't mean to cross that out. When you're talking about the volume of the prism, the volume is equal to the area of the base times the height. So what that means is, if I look at this, like if you're looking at something as simple as, whoops, it looks a little sloppy. You know, I get a little OCD. I'm getting so excited because I just enjoy this. Is that if we have this right over here, and I draw this in here, you should all be like, oh, that's a rectangular prism. And I say 6 by 4 by 2, right? Let's say that this is inches, 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 right? The area of the base is 6 by 4, right? Because that's the base right there. I'm going to assume that that's my base. So the area of the base is 6 by 4 times your height, which is 2. So this is going to be 6 by 4 by 2. And that is going to equal 48 cubic inches. So in other words, if I have, let me just make this a little bit smaller. So if I have, this is basically saying, let's say that this is 1 inch by 1 inch by 1 inch, right? So that's 1 cubic inch. How many of these 1 inch cubes fit into this box? So this is when we talk about how many, so this is basically saying how many 1 inch cubes fit into that box. Okay? That is literally what it's asking you. How many of those 1 inch cubes fit into that box? And that's what you're trying to find out. And then again, so now if I say to you, well, what if it's a triangular prism? If I had these drawn out, it would probably look better. But it's actually good exercise, so you can see how I'm actually drawing the triangular prisms. And you should pause and draw your own triangular prism after you see how I do it, right? Because what I like to do is draw it like this and draw it like so. And I'm going to make this a right angle here. So dot, 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 dot. Doesn't look bad, right? And again, make that a right angle. And I am going to make this, let's say that I make this 5. I'm going to make this 4, and I'm going to make this 2. And we'll go centimeters, 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 and I say, let's get the volume. So the volume of this triangular prism, that's what I'm on the hunt for. And you know that because the two bases are triangles, so again, the volume is equal to the area of the base times the height. So the base, in this case, like how I made that rhyme, the area of the base is a triangle, so it's going to be 1/2 your base of your triangle times your height, right? this is just the triangle, right? Let me just go back here. So when we're talking about the area of the base, we're talking about the area of the triangle, right? So here we're looking for, whoops, come on, Shar. We're looking for the area of the triangle, because that's what the area of a triangular prism is, that the base of it is, times the actual height of the prism. So if I said to you guys, who is the actual height of the prism? It's when you stand it on its base, which we are doing here. So this is the height of the prism. So that is the height of the prism. Okay, so that's who that is right here. But if I'm looking for the area of the triangle, take a look over here. I have a right triangle, and if I were to draw this right triangle out here, this is 4, this is 5, right? The area of the base, I need to find the length of this side right over here, and I hope you're all being like, oh, it's a right triangle, so I'm going to use pi, thag, swag. So you're going to do, you can call that x, so that's going to be x squared plus 4 squared equals 5 squared. I really hope at this point you guys realize that that's a 3, 4, 5 special right. So this does wind up equaling 3 when you go ahead and find it. So you find out that that's equal to 3 centimeters. So now if I want to get the volume of this prism, I can do the area of my base right here, because that's my base, because that's a 3 and that's a 4. So my volume is going to be equal to 1/2 times 3 times 4, and then times 2, because this right here is the area of the base, which I am then going to multiply times the height. This is the actual height of the prism. Okay, so that's going to be the actual height of the prism, and then I can go ahead and get the volume of this thing, because I can see that it's actually going to be 12, and it's going to be 12 cubic centimeters by the time it's all said and done. So that literally means that if I have 1 centimeter by 1 centimeter by 1 centimeter, 1 cubic centimeter, right? I can fit 12 of these little cubes into this space right over here, this 3-dimensional space, because that's what volume is, okay? So now what I want to do is I want to actually get the volume of this prism. And what's interesting is it looks like there's 2 different prisms here, aren't there? And I hope you're all saying to yourselves, yes, there is, because the bottom half looks like a rectangular prism, and the top half certainly looks like yes, it's a triangular prism. So what we're going to do, I hope you're saying, let's find the volume of both, and yes, we are going to add them together. So we are going to literally do that. So now when I look at this, the volume of the prism, the rectangular prism, is my base. The area of the base is a 4 by 2, so that's going to be 8 times 3. So this guy right here is going to be 8 times 3 is 24. So the bottom is going to be 24 cubic centimeters. But now I have to look up top here to find out the area of the triangular prism, right? Now, if this is 4 down here, I hope you're all realizing that that's 4 there also. And I mean, if you look at this, you can tell that this is a prism. So these are my 2 bases, right? The 2 triangles are parallel to each other. And if I said to you, how tall is it? The tallness of it is going from here to here, right? That's how tall it is. It's as if you took that, this other guy here, and we rotated it so that it's sitting in a different position, okay? So here we go. So when I look at this prism, I know that this is my base right here, and this is my height right here. And again, the area of a triangle, so my volume is going to be 1/2 times 3 times 4 times 2, and that is going to be 12 cubic centimeters. So therefore, the total volume is going to be 36 cubic centimeters. You got it, okay? So now, let's say we want to find the volume of something like this, okay? There's a couple of ways that we can certainly attack it. Definitely a couple of ways that we can certainly attack this thing. But for me, I'm looking at that and I'm like, okay, so this is 4 units here going across is 6 units. So what I like to do, and if I'm you, I would pause this and try to sketch this or print it out or something, or take a screenshot of what I have here. If you want to, hit pause, take a screenshot, and then print this thing out. Because what I'm looking at is that I'm like, okay, if this is 6 units over here, then it's going to be 6 over here. So I know that that's 6, okay? So there's a couple of things that are going through my beautiful mind that I know that if this right here is 4, that if I know, let me erase this, it's a little sloppy and I want to use a different colors. I love to use different colors, even though there's like 2 or 3 of them. That if this is 4, you guys should be able to tell me what the length of this is right there. And if you said 10, that's correct because this whole thing here is 14, so therefore this is going to be 10 right there. And furthermore, that if this is 12 units, you should be able to tell me what this is right over here. And the answer is 6 because this whole thing is 18. And I hope you guys figured that one out. So you could easily break it down and you could be like, okay, I'm going to break it down into 2 rectangular prisms. I can do all of that. But the other thing that you could do is I almost look at it as what is the volume of the entire, if I were to fill this space out right over here, if I were to fill this space out right here, right? Fill this out and I were to come out, right? What would be the volume of the big giant prism, right? And if I found the volume of the big giant prism, I could then subtract out this volume right over here, and that would give me the volume of the L. So that's one way to do it, right? So if I want to get the volume of this L-shaped figure, I could take the area of the giant prism, right? And then subtract that missing area. That's one way to do it, which I'm going to do first. And then you can go about, and I'll show you how to do it if you wanted to break it down a different way. So if I look at the volume of the box of the whole thing, if I were to fill it in, it's going to be 18 by 6 by 14. So this is going to be 18 by 6 by 14, right? And then I can subtract out the missing area. And the missing area, if you look at it, it's going to be 12 by 6 by 10. So this is going to be minus 12 by 6 by 10. So that's one way you can certainly do it, is to find the whole thing and then subtract it out. So, and I know some of you were like, that's not how I would do it. And that's fine, because we're going to go and do it the other way that you think we should do it, okay? Or what I strongly suggest is that if you think you know how to do it a different way, see if your answer comes out to the same as mine and hit pause right now. Okay, 12 times 6 times 10. So the volume should be 792 cubic units, okay? I don't know why the screen suddenly got dark. Oh, you know why? Because I unplugged it. Okay. Okay, so now we're back. And so that would be if you were to take the area, if you were to just find out the area of the giant cube and take out the area of the smaller, the bigger prism, and take out the area volume of the little prism, what that gives you. But then the alternative too is you can break this down into like this guy here, you know, this prism and then that prism, and then add those two together. And that might also work, and that would probably work as well. So this right over here, so I could find the volume of this. So if I were to find the volume of this, it would be 4, if you notice, it's 6 by 12, and it's 4 units tall. So this would be 12 by 6 by 4, plus, and then if we wanted to get the volume of this right over here, right, then this little piece here we know is 6, right, by another 6 by 14, and if we do 6 by 6 by 14, whoops, that should be times 14, Charlene, come on now, okay, by 14, so 12 by 6 by 4 plus 36 by 14, and sure enough, we get 792 cubic units. So whether you break it down into 2 prisms, or I go the big guy minus the little guy, notice we get the same volume. So whatever works for you is great. I just think it's important to know which way to do both, okay? This is a semi-cylinder. The volume of a cylinder, again, I can also call this a prism, by the way. Why can I also call a cylinder can fall under the family of prisms? It's a special kind of prism, but it's a cylinder. And if you said because the bases are parallel and they're both circles, your answer is correct, okay? So, which is fantastic. The cylinder thing here, so now that we have it, we know that we have our parallel bases are circles, right? Our parallel bases are circles. And then again, remember the volume is equal to the area of the base times the height. So the nice thing is this right here is our height, and then the base is in the shape of a circle. And that's why the volume of a cylinder Okay, so that's why the volume of a cylinder is equal to pi r squared, because that's the area of your base, times your height, right? That's the area of the base times your height. So here we have a semi-cylinder, but before we do that, let's do a full cylinder, right? So I'm gonna go over here, whoops, no, not yet. I'm gonna go over here, and let's say that, we got a can of soda, okay? And this is 18, and this is 17, we'll say centimeters, and we wanna get the volume of this, right? So if we want to get the volume, we know that it's equal to pi r squared times h, because again, the area of our base, right, is in the circle, times our height. But notice, what did I actually give you? That's correct. I gave you the diameter. So the diameter is 18, which means your radius is 9. So when we want to find the volume, the volume is going to be equal to pi times 9 squared times your height, which is 17. And that's going to be 81, which I already squared 9 times pi times 17. So your volume is going to be 4325.97 cubic, again, centimeters, because we're fitting a bunch of cubes inside this guy right over here, but we round them off and we cut things off just to make sure that they fit. So now over here, you guys are asked to find I shouldn't say surface area, I should say find the volume, okay? I'm going to have you guys find the volume. So you're going to be finding the volume for number 5. This is on you guys. And think about how much of that cylinder, because it's a semi-cylinder that we're finding. So you are responsible for doing this problem here. So you guys are doing, you do, number 5. And then, nearest cubic centimeter. So you are going to find the volume of this guy. So take a look at what you got there, and I'm curious to see what you guys are cooking up for this one. But you guys, like I said, are responsible for doing number 5, which was back there, and then somehow we jumped all the way up to number 10. You are responsible for doing this one as well. Okay? I will note that in Canvas, but just know that it's completely on you guys to do that. And I'm really looking forward to doing more volume stuff, but I think that this is a really clever problem, and I look forward to seeing what you knuckleheads come up with. And have a great day.